For section 9.3, we're going to be talking about inferences about two proportions. So instead of hypothesis tests or confidence intervals about two means, now we're looking at two proportions. And basically, there's just some times when you need to compare the percent, proportion, or ratio from different populations. Again, we're going to try to focus on them being independent populations. Perhaps you want to study if the percent of female students who pass this class is greater than the percent of male students, or some other definition. Okay, so in terms of notations and formulas, I just mentioned we're going to need our populations to be independent, and we're looking at the proportion or percent of these populations. To keep them straight, again, we will be using subscripts. So for example, p hat 1 and p hat 2, and so if that's the case, then we will also have q hat 1 and q hat 2 and n1 and n2, all sorts of stuff like that. But here's something else that might happen when it comes to proportions, is we may have to calculate p hat using the formula p hat is x over n, but now it's going to have a slight twist in the sense that we're actually finding p hat 1, which is x1 divided by n1, etc. So all we're really doing is putting matching subscripts. And in the past, if we were given p hat, then we didn't actually need to calculate it, and if we didn't need to calculate it, we didn't need to know what x was. But in the formula we're going to be using in a few minutes, we do need x as a piece of our formula. So we had learned that x, the number of successful items from the population, is found by taking the total population times the percent of successes to get the number of successes. And in that section we learned to always round to the nearest whole number. So for example, if I'm asked to find x for the following data, I don't know what the reference is, but I have 30 people, 30 dogs, 30 pages, whatever it may be, with a 42% success rate. So using the formula above, x equals n times p, I'm not really worried about subscripts at this point. Then I'm taking 30, the number of items I'm studying, the percent of success, or the category I'm looking for, and as I multiply those, I get 12.6. But I'm going to answer with 13 because we need to round our answer to the nearest whole number since it's discrete data that's being used. Next problem. In a group of 200 people, 33% agree on a topic. How many people agree on the topic? We're going to need that x. So again, I start off with my formula, n times p. N is, I wrote 220, but it is 200, and I did the math correct. 33% of the population, let's go ahead really quick and make that a 0. And when I multiply those, I get 66. I thought this example was important to use because in the past, people have tried to change the 66. Do not bump it. It's not a sample size. If you need to, think of 66 as 66.0, and when you round, oops, sorry, wrong pen. When you round on that 0, you're still going to round to 66. So our answer is 66. Hey, we didn't write the answer to the last one. Let's go ahead and copy that 13 into our answer box.